next, guys, is motion in a vertical circle. Okay, now what I want us to realise is that when you have an object and your object is currently, let's say, falling under gravity, let's give it an initial velocity of u equals 5 meters per second. Okay, now it's falling underneath gravity, and then later on in the question, what would we call it? We'll just give it a random number above the ground. We'll give it a random number of, let's say, 20 meters above the ground. Are we happy with that? Then we let it drop 10 meters, so it's now 10 meters above the ground. And what velocity will we be going when we're 10 meters above the ground? Now, most of you will jump to UVAS and say, look, UVAS can sort this out, no bother. I'm going to use the principle of conservation of energy. Conservation of energy. So energy is stored in the form of two ways: kinetic energy or potential energy. Potential energy, you've probably done this already, haven't you? mgh, mass by gravity, by your height above the ground. Kinetic energy is a half mv squared. So kinetic energy is the energy a moving body has, while potential energy is the energy it'll have because it's above the ground. So right now my pen has potential energy. Let it drop. All its potential energy is gone. Okay, so what we're going to do here, guys, is this. We are going to, so I can give it a mass. I can give it a mass of 2 kilograms. Okay, just to make the question complete. So start off with your potential energy. So P1, potential energy at the beginning, plus your kinetic energy at the beginning, equals your potential energy at the end, plus your kinetic energy at the end. I want to find out how fast am I going after I drop 10 meters. So here's how you do this. Your potential energy is going to be mgh, which is 2 kilograms times gravity. You're currently at the start, you're 20 meters above ground. Your kinetic energy is a half mv squared, your mass being 2. Your phi squared, I said you were going at 5, didn't I, at the beginning? So your speed at the beginning is 5, so that is mu squared technically, which is going to be times 25. Equals your PE2, your potential energy. You're now 10 meters above the ground, so it's going to be 2 times gravity multiplied by 10, and then you're going to be a half mv squared, which is a half, 2. You don't know v, that's the whole point of the question. What is v? V squared. So a half 2 times v is v squared. That there is going to be 20g. Over here we're going to have 40g. And that's going to be a half of 50, which is 25. Then we're going to find out that our phi squared is going to be 20g plus 25 equals phi squared. 20g being 20 times 9.8. So 20 times 9.8 plus 25. Square root your answer, the square root of 221. So the velocity we gained, we went from 5 meters per second to 14.87 meters per second. So our loss of, we were at 40 G's potential energy, we now have 20 G's potential energy. We lost 20 G's worth of potential energy. All that potential energy got converted into making the kinetic energy faster. So making you go faster because you're falling underneath gravity. This brings me to our question. You're going to have 2 ways of doing these questions. These are motion in a vertical circle. So the force is up versus force is down, business is over. Okay, so what you're going to do is 2 different things. You're going to do this system here, P1 plus KE1 equals P2 plus KE2. That's going to happen a lot. You're going to use your 2 formulas above. So every question, without failing, this whole exercise has this little system in here at work every time. Okay. Step 2 is you're still going to use your centripetal force. Fc equals mv squared over r, or Fc equals mr omega squared. Okay, one or the other. Alright. Now, how we resolve the forces is different this time. No matter where we are in the circle, we're always going to resolve the forces along the radius of wherever that object is. So if the object is in position 1, we're going to resolve the forces parallel to the radius and perpendicular to the radius. If the object is over here, same deal. We're going to resolve the forces this way and that way. Everybody got it? It's always going to be parallel and perpendicular to the radius that object makes with the centre of the circle. Every time. So, going to look at this question now. Have a good read. A particle hangs freely from a point O by means of a light inextensible string of length L. The particles project horizontally with initial velocity root g 3gl. Show that the string will become slack when the line OP makes an angle cos inverse 1 over 3 with the upward vertical. So, what we're doing is this, guys. We have an object like so. It's currently down here. We give it an initial velocity. I'll make this a bit shorter actually. And what happens is, so just make that a bit shorter for a minute. So we hit it with a motion, okay? And then what's going to happen next is when we hit that, what's going to happen is this here is going to keep going upwards. The pendulum goes upwards, and then eventually it's going to reach a height where it becomes slack. Everybody happy with that? So to reiterate, we exert a force on it down here. It's hanging straight down with a weight at the end. Okay? So the particle is the blue box. It hangs freely. We give it an initial velocity root 3gl, and then it goes all the way up, and then it eventually becomes slack, and then it starts falling inwards. Now, show that it makes an angle this with the upward vertical. Okay, so what does upward vertical mean? So if we have a cross thread here, the upward vertical is this angle in here. Let's call this cos theta. Everybody happy with that? Now, can anybody tell me what force is at play keeping this particle in position? What force is causing it to move in this semicircular axis here? This path here. What's causing it to stay in the circle? What force is causing it to stay moving in the circle? Tension. Okay, it's connected by a string. Okay, so we got tension there. Okay, so tension acting inwards here. Okay. Now, remember what I said earlier on? You're going to resolve it parallel and perpendicular to the radius at which the tension acts. Okay, so what other forces are at play? What about mg going directly down? Everybody happy with the mg there? Now, I'm going to break up mg into its components. Any idea how to break up mg into its components? What angle do you think this is? Sorry? So let's do this, okay? Alternate angles makes that one theta. Makes that one 90 minus theta. Makes this one here theta. Is that alright? Everybody to figure that out? Alternate angles 90 minus theta theta. So, book has a different way of setting up than I do. I always tend to set up like that. So, your mg is your hypotenuse, right? So mg is the hypotenuse of that triangle there. Now, what about this part here? Going directly down, going along the same parallel to this. Anybody? Mg cos theta. And then this one here. Now, to get back to what you were telling me, you said you could figure out what cos theta is. Actually gives it to you, doesn't it? Cos theta is a third. It means that's a 1 and 3. Do Pythagoras' theorem. Figure out that the other side is root 8. Is that right? So, 1/3 mg is what you were telling me there. And what about this mg sine theta? Root 8 over 3. Okay. As it turns out though, we don't really need the root AMG, okay, because we're going to be talking about it going in. So, let's work on centripetal acceleration. Let's work on this one here. Formula 2 as opposed to the first formula, okay? So let's work on formula 2. What force is driving it towards the center of the circle? Tension plus mg cos theta, otherwise known as a third mg. So that's, does everyone understand that the mg cos theta, this part here, is also aiming towards the center of the circle? Then equals mrw squared. So m, what's our radius? Anybody know the radius? L. Okay, am I using m or omega squared? Oh, sorry guys, excuse me. Excuse me. See the way it's mv squared? K equals mv squared, yeah? And see the way I chose m or omega squared? They're not compatible with each other. So, what I have to do is I made the wrong choice there. I'm actually using mv squared over r. I don't know if anybody noticed that. If you noticed it? No. Okay, so mv squared all over. Now what's the radius? It says it's of length L, doesn't it? So that's it there, okay? So we have a system of equations there. Now, next thing we're going to do is we're going to take down, So, what we're going to do next is we're going to look at the potential energy system. So this system here. Now, what you do is you take something as your ground level. You specify something as your standard position. Now, standard position is where you have you will have no potential energy. It's like ground zero. So I'm specifying this here as my ground zero. H equals 0 here. You have no height. Is that right? Now, at the start of the question, do we have any potential energy before we start moving up? Do we have any potential energy at the start of the question? So, this here being the start, this here being the finish. Any potential energy? No. PE1 equals 0 because it's mg multiplied by 0. No good there. Okay, so 0. How much kinetic energy do we have? I have m. Now what's phi squared? It says phi equals root 3gl. Phi squared therefore 3gl. Alright? 3gl. Potential energy 2. How high are we above the ground at the end of the question? It's mg multiplied by some sort of height. We don't know what height it is yet. Can anybody tell me what height it might be? Now, let's look at it this way. If I move this directly across, can you see me moving this directly across here? That's its height above the ground. Would you agree with that? It's still height above the ground. You have L is from here to here. Everybody agreed? So I need to find the distance between the two blue dots. So it's going to be L plus something. Now what is the height? So what we can do here is we can do because I'm done with all the forces here, I can just work these out for 1 second. So what I suggest we do this. This is L. So the distance between the two blue dots must be L cos theta, otherwise known as 1/3 L. Is everybody happy with that? So it's your initial L plus another third L going up. Okay. Just one thing. Do you know why we've been using cos theta equals a third, right? The question was to show that, so we just actually have to leave it as theta for the time being, and I'll prove it. All the work we did, still grand. Okay, so just let me adjust one thing here. What I have to adjust is, see this, see the way that was a third mg? It's actually going to be mg cos theta, and the goal of the question is to prove that it's a third. Okay, so I'll just reread the language of the question there. Okay, and so that means that instead of using the third L, we're still going to use L cos theta. So L plus L cos theta. Now guys, we have our two equations now. We're going to tidy them up a little bit. And what have I left out? I haven't put in the kinetic energy 2. So I haven't put in the kinetic energy 2 either. So what's the kinetic energy 2, guys? So it's still moving. Half mv squared, guys, because you're still moving up here. It comes slack, right, but you're still moving at a half mv squared. Okay, when you get to the top there. Okay, so half mv squared. Now, the compatible part of both equations is what, guys? The compatible part is the mv squareds. I want you to remember that. The mv squareds are the key to getting these questions out. Okay, so what I'm going to do is this. I'm going to do 3 over 2 mgl. This mgl goes over the other side, minus mgl minus mgl cos theta equals a half mv squared. Going to do next is the that's going to be a half mgl, isn't it? The two of them combined get me a half mgl. Okay, multiply everything by 2, and I get a mgl minus 2 mgl cos theta equals mv squared. I'm just going to leave that mv squared where it is. Now, see my other equation down here? My t plus mg cos theta equals mv squared over L. Everybody alright with that? T plus mg cos theta ends up to be T plus mg cos theta ends up to be what we have here. mgl minus 2 mgl cos theta all over L. The L's will cancel. And what we're going to be left with is that T equals, bring that over the other side, we're going to get mg minus 3 mg cos theta. How many variables in this equation? What are the two variables? T and theta. Okay. Key word in the question is becomes slack. What does that mean? Tension equals 0. So all this here equals 0. Mg minus 3 mg cos theta, and then long and behold, we're going to get 3 mg cos theta equals mg cos theta ends up to be the mg is cancelled to become 1, and cos theta equals a third. Okay.